Hello everyone, I'm Dr. Nan Hu. I want to talk about statistical inference in this lecture. I will divide this lecture into two blocks. In the first block, I will talk about estimation and precision. Here are the objectives for the whole lecture. First of all, I want you to be familiar with estimation precision in terms of the statistical parameter called standard errors and also the confidence interval. Also, we want you to recognize how a sample size is used to infer information about the population. And be aware of terminology for statistical hypothesis testing. Lastly, I want you to recognize how sample size influences statistical power in a hypothesis test. Here's the overview of this block. First of all, I want to introduce statistical inference. And then I want to talk about estimation precision and confidence intervals. Statistical inference. So the goal of statistical inference is to use sample statistics, for example, sample means and sample median, to estimate corresponding population values, such as population mean and population median. Estimation precision and confidence interval. First of all, I want to know how close is the estimate to the true population value when you use a sample value. Statistical theories, especially the theory called central limit theorem, is used to find distribution of sample statistics, as if we could repeat sampling over and over again from the same population with the same design. So this will guarantee that we have a sampling distribution for the sample statistics. And the standard deviation of the sampling distribution of the specific measurements is called standard error. And this is the measurements to see the variability or lack of reproducibility of the sample statistics. Also, we can use the standard error or other information from sampling distribution to construct a confidence interval for the population parameter. In terms of standard errors, there are a lot of standard errors for different type of population or sample parameters. In general, there are theories for estimating standard error for many other types of sample estimates other than just the sample means. So for example, we can estimate the standard error for percentiles, such as quartiles or quintiles, standard deviation, regression parameters, odds ratios, or the difference or ratio of the two estimates. Standard error generally decreases with the rate of 1 over the square root of n, where n is the sample size. So this is to say, the larger the sample size of the observations, the smaller the standard error, and the higher the precision. Here are assumptions for estimating 95% confidence intervals. If the following are true for sample statistics, then we can estimate the 95% confidence interval, which is within approximately 2 standard errors of the true population value. The three assumptions are: the sampling distribution is approximately normal or Gaussian. The sampling distribution centers at the true population value, and we have computed the correct value for the standard error. Here is the formula to calculate the 95% confidence interval. In general, because of the central limit theorem, we can estimate the confidence interval using the point estimate minus and the plus about 2, but actually the exact value is 1.96 times the standard error. The interpretation of the 95% confidence interval is there is 95% chance that the population value lies within the interval. This is to say, if you do the experiments 100 times, there will be about 95 times you see the sample value is within the interval. Alternatives to 95% confidence intervals, including 90% and 99% confidence interval. And if the three assumptions we introduced in the previous slides are all correct, exact confidence interval for the true population values can be computed in this formula. For example, 95% confidence interval is equal to estimate plus minus 1.96 times the standard error. But 90% interval in general will be narrow. It will be equal to the estimate plus or minus 1.645 times the standard error. And also 99% confidence interval will be much wider. It's equal to the estimate plus and minus about 2.57 times the standard error. Practical use for confidence intervals. First of all, it will help us to rule in or out clinically important differences. Secondly, it's important to guide study design. So we want to know what sample size is needed so that the estimate will be useful, precise, or certain hypothesis test will achieve a given power in the hypothesis testing. In summary, in this block, you learn that inferential statistics use sample parameters to make inferences about population values. And you need to understand that sampling distributions are usually used to infer that population value. Second, standard error is the parameter to describe the precision of the sample parameters. And usually, it can be used to build up a 95% confidence interval for a sample parameters. This is all in this block. In the next block, I will talk about hypothesis testing and also the sample size and power for a certain hypothesis tests.